Okay, question 9 says a curve is such that the second derivative is this. It is given that the curve has stationary point at this point, 1/2(9). Use the expression for a second derivative to determine whether the stationary point is a maximum or a minimum. Okay, to find out the nature of the stationary point, that it is a maximum or a minimum, if your value at the given point is greater than 0, then it is minimum, and if it is less than 0, then it is maximum. So let's substitute your x coordinate of your point in the second derivative. The second derivative at x equals to 1/2 will give you 6/1/2 to the power 4 minus 5/1/2 to the power 3. Okay, so if you substitute these values, what you are getting, okay, 16, 6 times 16, 2 to the power 4 is 16, minus 5 to the power, 5 times 8, 6 times 16 and 5 times 8, not power. Okay, so this will be solved to give 56 will be your answer. So as this is positive greater than 0, so we have a minimum value at, like, the nature of the stationary point is that we have a minimum. Okay, find the equation of the curve. That seems interesting because we have second derivative and we need y. Okay, we have d square by dx square, but we need the y. So we have to integrate this twice. First time when you will integrate the second derivative, you will be getting the first derivative, and when you will integrate this first derivative, you will be getting the y, equation of the curve. So integral of this derivative would be 6/x to the power 4 minus 5/x cube. First of all, we cannot integrate it in the denominator, so we have to rearrange this a bit. So we'll be getting 6x to the power minus 4 minus 5x to the power minus 3. Integrating it will give you 6x minus 4 plus 1 over minus 4 plus 1 minus 5 times x minus 3 plus 1 over minus 3 plus 1 plus the constant of integration. Okay, and the right hand side we are left with dy by dx. So solving this will give you 6/-3 x to the power minus 3 minus 5/-2, or you can say plus 5 with 2 x to the power minus 2 plus c. Okay, now the first, without prior to integrating it again to find the equation of curve y, we have to find the constant of integration first. So how can you find, is there any given condition that we can use to find the constant of integration? As we are being given that at this point 1/2(9), this is a stationary point, so we know at the stationary point we have dy by dx equals to 0. So if we substitute the x coordinate of stationary point and we put this first derivative equals to 0, we can get the constant c. So 1/2, if we substitute in here, we will be getting your equation is this, equals to dy over dx. So on stationary point, dy by dx is 0. So that means the 0 is equals to minus 2 1 over 2 to the power minus 3 plus 5 over 2 to the power, or times 1 over 2 to the power minus 2 plus c. Solve this, it will give you minus 2 2 times 2 to the power 3 plus 5 over 2 2 to the power 2 plus c equals 0. So this will give you minus 16 plus 10 plus c equals 0, and this will give you c equals to 6. Okay, so let's substitute it back in the equation of first derivative. Plus 6. Now integrating again to get the equation will be equals to minus 2x to the power minus 3 plus 5 over 2 x to the power minus 2 plus 6 dx. It will give you minus 2x to the power minus 3 plus 1 over minus 3 plus 1 plus 5 over 2 x to the power minus 2 plus 1 over minus 2 plus 1 plus 6x. And yes, again the constant of integration, because we have integrated it again, so plus c, or you can differentiate this c with the other c as c1 and c2, but as we have already found it, so no need to do that. Just simplify it first and then look what else we need to do. Minus 3 plus 1 is minus 2, and minus 2 can be cancelled out, so we will be just left with my x to the power minus 2. Minus 2 plus 1 is minus 1, so minus 5 over 2 to the multiplied by x to the power minus 1 plus 6x plus c. Now to find out this c, we have another condition, and that is that this point 1 over 2 9 lies on the curve. So we have x and y both coordinates, we can substitute to find the c, 1 over 2 and 9. So y will be equals to 9 equals 1 over 2 to the power minus 2 minus 5 over 2 1 over 2 to the power minus 1 plus 6 times 1 over 2 plus c. Now solve it. 2 to the power 2 minus 5 over 2 to the power 2 times 2 plus 6 over 2 will be 3 plus c. It will give you 4 minus 5 plus 3 plus c equals 9. So 9 plus 5 is 14. 14 minus 7 would be 7. So c will be equals to 7. So now write the equation of the curve properly with the constant of integration, and also taking into account the powers of x to be correctly written. So we can write it to be 1 over x square minus 5 over 2x plus 6x plus 7. We can write in either ways, these both will be considered correct. Okay, so this is how we found this whole. Firstly, we had to use this maximum and minimum thing, that if after substituting the x value your second derivative is greater than 0, then it means it's minimum. Secondly, to find out this constant c, you used dy by dx equals to 0 and substituted your x equals to 1 over 2. Okay, and lastly, to find the second constant of integration, we are using the point 1 over 2 9 because it lies on the curve. Okay, and this is how we found our equation of the curve. I hope you understand this question.